Hey class, so real quick, I know there's not really much homework for this one for lesson 7, but if you were absent, I want to make sure I do a quick overview of what you missed, and then also homework is the last 2 problems I'll cover. It's just writing a CER. We're going to be looking at transformations here. In this case, we'll talk about translation, which means to slide, reflection, which means to flip, and rotation, which means to turn. Translation rules. Remember, if you're going on the y-axis, you're either going up or down, which is positive or negative. Or on the x-axis, you're going right or left, which is either positive or negative. We wrote this in our books. If you have not written this rule or the reflection rule, you need to pause the video and make sure you add this to the ridge transformation notes. If you need to change the page and write 1B, you can do that for your notes as well. So when we reflect over the x-axis, the y value changes, and that's because we're moving up and down because the x-axis goes this way. Reflection over the y-axis, we're going to change the x coordinates. Remember, y goes up and down. So if I jump, I'm going left and right. Okay, I showed this here. One thing you want to do is, as you read this, and we did this in class, you want to make sure you know what axis you're reflecting over, even if you need a circle right here. I am going to look here. I notice 1 point and 2 others. They're in different parts or different sides of the axis. In this case, it's 1 spot from the line of reflection. So I'm going to go 1 spot up. Since I was 1 spot down, I went 1 spot up. And I'm going to write my W prime. For C, I'm 1 spot up from the line of reflection. So now I'm going to go 1 spot down. Oops. It's a little sloppy, but you can get an idea. And here I have K. From the line of reflection, remember X is my line of reflection. I'm going to count 1, 2, 3, 4. And K will be 1, 2, 3, 4. And I will make another dot and put K prime. Mine won't be too perfect, but I will try to connect them. Okay, and now you can see the reflection over the x-axis. We just want to make sure we're watching our rules. So today we're really focused on reflection and translation. And next week in class, I'll do a mini lesson with rotation. I'm always going to want to check what my rule is. In this case, my rule is I am translating 4 units up. Translation is going to be what I'm doing, and how I'm doing it is the 4 units up. So I'm going to slide since I'm translating. E is going to go 4 units up. 1, 2, 3, 4. I am going to count each point 4 units up because I am translating, which means I am sliding each point. 1, 2, 3, 4. And that's L. And it's okay if you write off the grid. And you're going to do this for each one. 1, 2, 3, 4. And I. And the last one is R. 1, 2, 3, 4. If you're making the whole thing move 4 points up, each point goes 4 points up. I will try to do this best I can. And my shape looks very crooked, but you get the idea. Okay, make sure you see how I did that. This one here you do need to do. So page 54, if you were absent, you need to make sure you follow along. You can use patty paper, or you could just simply count and pay attention to, if you move this over, like it says polygon A to polygon P, write the lengths of each side. So we want to slide it, and it will eventually move there. So what that looks like, again, all you do, the top has 2, I'm going to go 2. This part has 2, I'm going to go down 2. This one has 1. I'm going to go to the right one, and so on. It's counting the side lengths and matching it till your shape follows. Now, the one thing I want you to notice is here, this one corresponds with this. This corresponds with this. That means if I were to move this over, this line matches with this line matches with this line. It's called corresponding side lengths. For here, if I would take the 90-degree rotation, I would draw this with my patty paper. I would write the degrees, and then I would rotate right since it says clockwise. Put your pencil on R, and it would rotate to this. Now you would be looking for the corresponding angles and side lengths. In this case, this corresponds with this piece. This 90 corresponds with this. So you can know this side length corresponds with this side length since they have the same degrees. And let me highlight this for you so you can see what I'm talking about. But this side length here and this side length here, okay? One more time, if we did a reflection, we could flip it, and where would the degrees land? So as you see here, the 90 lands over here. These are called corresponding angles. Okay, the side lengths, corresponding side lengths. This is taking 2 and 0.4 of the square, and so is this side length. You can see after the transformations that the degrees of the angles are in different locations, so we want to mark them. That's on page 55. My last piece and the last part of the lesson is the ridge transformation. One thing you want to remember is it does not change the shape or the size. So if the size or shape is different, it is not a ridge transformation. It is something else. Okay, one thing I want you to do is pause the video. This is your homework. If you didn't finish in class, 59 was for 1 and 2. You're going to write out a CER. What you're going to do is you're going to draw the shape. Sorry, that's the bell. Draw the shape, and you're going to do transformation, slide, flip, and turn. If it doesn't match up, like in this case, you are going to write a CER. Here's an example. My claim is figure P and Q cannot be a ridge transformation because they are not the same shape and size. When I take my patty paper and trace, I'm able to see they do not match up. Some of the side lengths are the same, but they do not tilt the same way. Therefore, each leans differently, causing the shape to point up in different locations. So they're not a ridge transformation. That is a clear CER giving my claim using the side lengths because they are not the same size and not the same shape. Hope this helped. This is especially the overview if you missed lesson 7.